Assalamu alaikum. Bismillah ar-Rahman ar-Rahim. In the name of Allah, the most beneficent and the most merciful. Guys, again I'm going to solve a question where we have to find the domain of the function, right? So the question I'm going to write right now is your question. The question is let x belongs to open bracket 0 comma pi over 2, right? Means it is mentioned here that x belongs to 0 to pi by 2. Okay, means from 0 to 90 degree. Then we have to find the domain of fx. Find the domain of fx, which is equal to 1 divided by square root minus log base sin x tan x. This is the question. This is your you can say this is your function. Fx is equal to 1 divided by square root minus log base sin x tan x, and we have to find the domain. But remember one thing in your mind, that the x belongs to 0 comma pi by 2. Okay, so this is my question, and if you see, the question involve a trigonometric function as well as the square root function and a rational function. See, so if you see 1 divided by, it is a rational function, and here if you see, this is a square root function, right? So I'm going to solve this question here. See, so first of all, if we consider here, if we consider that here, this is what the denominator, you can see this one minus log base sin x tan x must be greater than 0, right? See this question. If this value is greater than 0, then we can say 1 divided by square root and any positive value, the function exists, right? So here there is a condition that minus log base sin x tan x must be greater than 0. Now we are going to solve this question. So if we divide by minus, so it can be written as log sin x, log base sin x tan x, and here it must be what, less than 0, because when I'm going to divide by minus, the sign of inequality always change, right? So log base sin x tan x less than 0, right? So here I want to tell you something which is very important. So here, you know, this is your sin x. If you draw the sin x here, the graph of the sin x, okay, this is the graph of the sin x. If we say about the x is given from 0 to pi by 2, right? This is your pi by 2, and from 0 to 0 pi by 2, the maximum value of the sine is 1. Means you can say when x is pi by 2, then the value of the sine x is 1, right? So the sine x from 0 to pi by 2, the sine x is always what, from 0 to 1. Means sine x is always greater than 0 but less than 1 for x belongs to 0 comma pi over 2. See, if the value of x is greater than 0 and less than pi by 2, you always see that the value of sin x is always greater than 0 and less than 1. It means the value of the base is 0 0.1, 0 0.2, 0 0.3, 0 0.8, 0 0.9. The base is here not greater than 1. The base here is less than 1, means greater than 0 and less than 1. It means, I told you in my previous lecture, when you are going to draw a graph of logarithmic function, you must notice what the base is given. So here we know the base is greater than 0 but less than 1. So it means the graph of log, here I'm going to mention here, if log ax, okay, if the function is given y is equal to log base ax, where a is greater than 0 but less than 1, then the graph of the log, here I'm going to mention here, the graph of the log is always this one, right? This is very important. The graph never comes from the down, it always comes from the up. When the value of a is greater than 0 but less than 1, right? So here we can say this is the graph of log base a with x, where a is greater than 0 but less than 1. And here already I told you in the logarithmic function we must have two essential points. The first point, we have this coordinate which is 1, 0 always, right? And the second, as you see, this a is greater than 0 but less than 1, so it must be somewhere else, right? For example, if I say here, okay, and I say when this x, remember, when this x, the second condition, when this x is equal to a, when this x is equal to a, at that time the value of the y is 1, right? So, and here I know the value of a is greater than 0, so the a must be from 0 to 1, right? So for example, if I say this is your a, for example, right? So if you just go there, right, here in this case I can say where x is equal to what? A. If this x is equal to a, if this x is equal to a, because you can take anywhere a, right? This is 0.1, 0.2, 0.3, 0.4, anywhere. So if this x is equal to a, at that time we can say log base a, the answer is always 1. So guys, here you can see this is 1, right? This is the graph of log base a with x, where a is greater than 0 but less than 1, right? So here you can see, guys, if the value of, here if you notice this one, right, if the value of the x is greater than 0 but less than 1, the function has the positive value, and as x is greater than 1, the function has negative value, right? So here you can see, it's a very important question. The graph of, here the graph of log base ax is this one, right? So here, let's see this one. We want this value less than 0. Check this one here. This value, the whole value I want less than, means less than 0. So can you see here? Can you see here this part? Okay, if I say here, this is the graph of log base ax, right? If here, if x is greater than 1, what will happen? If x is greater than 1, if x is 1, the function has 0, right? But if x is greater than 1, what is the nature of log base ax? This will be always less than 0, right? This is very important condition. You can see when the x is greater than 1, then the log base ax is always less than 0. So here you see, if you have this one, here is a tanx, right, which is working as a x. So if you say the value of the tanx, is what? Greater than, you can see here the same things here, okay? I'm going to write down here, if the value of x here, right, x is greater than 1, the whole function, so I'm going to write down here, right? So you can say x is what here? It's a tanx. If the value of the tanx is greater than 1, right? If the value of x is greater than 1, right? If the value of x is greater than 1, means if tan x is like, for example, 1.1, 1.2, 1.3, 1.4, 1.5, right? here, so the log is always negative. So we can say when the value of tan x is greater than 1, right? When the value of the tan x is greater than 1, we can say the function, this one is always a negative value, right? Log, you can say log sin x 1.1, 1.2, 1.3, 1.4, and whatever, you always get this value negative, right? So now we are going, we just find out this condition, and now we are going to move for the next step. Here you can say this is tan x, and the 1 can be written as tan pi by 4, right? Because tan pi by 4 is always, you can say 1, right? Tan 45 degrees always 1. So the value of x must be, you can say x must be what, greater than pi by 4. As we know, the range of the tan is a real number, right? So here we have to take pi by 4. It's not pi by, the value of the x here greater than pi by 4, because if we take the value of x is greater than pi by 4, we will find out that the value of x is greater than 1. The tan x is greater than 1 when x is greater than pi by 4. But here the restricted domain is already mentioned that a maximum value we must take is pi by 2. Pi by 2 means 90 degree, and here you can say the greater than pi by 4. So we have a condition that the domain of the given function, the domain of the given function is greater than pi by 2 as pi by 4, right? And the maximum is what, pi by 2, because the maximum value of tan pi by 2 is 1.57, something like this one, right? So 1.57 is what, the greater than 1, right? And pi by 4, greater than pi by 4 is already what, the greater than 1. So and the maximum range is given, right, pi by 2, right? So if the value of x is between pi by 4 to pi by 2, okay, the tan x in this condition is always greater than 1, and when this is greater than 1, the log base sin x, tan x is always a negative value, and when this is negative value, our function exists. So we can say the domain of the given function belongs to minus pi by 4 to pi by 2. I hope guys you all understand. Please watch my next video where I'm going to give you a detail of a trigonometric function, as well as we are going to find out the domain of a function. Take care. Bye bye. Assalamu alaikum.